Hello and thank you for tuning into this discussion on multi-product ordering problem described in Chapter 5 of our textbook. So what we're looking at here is we have two different products. There's hex nuts and molly screws that we have to order from the same supplier. Now if we look at each of these products individually, we could of course come up with the respective optimal order quantities and respective individually optimal total costs. However, the system also has an associated total cost as well. Now the question is, could we actually do better if we decided to line our ordering of both products? So in other words, rather than ordering one product independently off the other, could we order both products at the same time and thereby save order placement costs and ultimately lower total costs for the company? So to answer this question, we're going to start off by taking a look at the two products independently, and we're going to start out with the hex nuts. So we need to calculate the EOQ for hex nuts as simply the square root of 2 times annual demand times the order placement cost K divided by the holding cost unit per year H. So I'd get an EOQ for hex nuts of 10,328. I can then also calculate the associated order interval, and that is what I call T of Q here. So T of Q is simply the time that elapses in between order placements. So we can simply calculate this as Q divided by annual demand and multiplied by 365. So this means that in this case we would be placing an order for 10,328 units every 108 days. You will see in a moment why we needed to calculate this number. What I want to do now is calculate the total cost for hex nuts, which as always is simply the sum of order placement and holding cost. So it would be equal to annual demand divided by Q. That's the number of order placements per year, multiplied by the order placement cost K. Now I'll add that to the holding cost, which is Q over 2 times H. So you see, looking at hex nuts only, I would end up with a total cost of $387.30. Now I'll do the exact same thing really quick for molly screws. These are, of course, the same exact calculations. So again, we're looking at the order quantity. That is the square root of 2 times annual demand times the order placement cost divided by H. We're again calculating the order interval as Q over annual demand, lambda, multiplied by 365. So now you see the issue here, the ordering pattern for the two products are not aligned. And again, the question is, wouldn't it make sense to align them and thereby cut down on order placement costs, assuming that we would incur the order placement costs only once if we ordered both products at the same time? Now let me conclude by calculating the total cost for molly screws as well, which again is annual demand divided by Q multiplied by the order placement cost K and the holding cost Q over 2 times H. So you see I'd get a total cost for molly screws of about $516. So the total cost would be, of course, be equal to the sum of these two individual costs. Now I want to take a look at the three scenarios to the right of the worksheet here. In the first instance, I want to take a look at what would happen if I forced molly screws to follow the ordering pattern that is optimal for hex nuts, and then we'll reverse the scenario. We'll take a look at what would happen if we force the hex nuts ordering pattern to align with that is optimal for molly screws. And then finally, we'll take a look at a solution that may be sort of a combination of the two, if you will. In other words, we'll find another interval that is globally optimal for both products simultaneously. So let's start out with scenario number 1, joint ordering based on the hex EOQ. If we follow what is best for hex EOQ, then the order interval would be 188 days. And we also know that in that case, the order quantity for hex nuts would be equal to 10,328. Now what we need to do is we need to figure out what would then be the order quantity for molly screws. Well, it would simply be equal to the order interval divided by 365, multiplied by the annual demand volume for molly screws. In this case, you see we would get an order quantity of 7,230. Again, this means if we were to place an order every 188 days, we would actually obtain an order quantity for molly screws of 7,230. Notice, of course, that this is not optimal for molly screws. Now the next question then, of course, is what would be our total cost in this case? Well, I can actually answer this quite easily, simply because the total cost will now comprise three elements. Number 1, the annual order placement costs, then the holding costs for hex nuts, and the holding costs for molly screws. This figure right here of 387 includes the annual order placement cost and the holding costs for the hex nets. So really all I need to do is add here the holding cost for MOLLE screws, which of course is Q over 2 times H. So you see, in this scenario, I would get a total cost of $731, much less than what I would have obtained if I were to order the two products independently of one another. Now we'll take a look at the alternative scenario, which is forcing hex nuts to follow the ordering pattern for MOLLE screws. So in this case, we will place an order every 142 days, and in that instance we would obtain a MOLLE order quantity equal to the EOQ of 5,429. And for hex nuts, we can again calculate the order quantity as 142 divided by 365 and multiplied by the demand volume for hex nuts, that is 20,000. So you see, in this case, we would get an order quantity for hex nuts of 7,756. Again, what we're going to do is we're going to calculate the associative total cost. And again, it will be the sum of the annual order placement cost and holding costs for hex nuts and MOLLE screws, respectively. Again, I make my life a little easier here by starting out with a total cost that is optimal for MOLLE screws, because in this case I'm doing what would be optimal for MOLLE screws. And remember, this figure of $516 includes annual order placement costs that now also covers hex nuts as well as the holding costs for MOLLE screws. So all I need to do is add in the order cost for the hex nuts, which is the associative order quantity Q, divided by 2 multiplied by the appropriate value of H. So you see, in this case, I was now able to lower my total cost quite a bit further to $661. And of course, the final question is, well, could we do it even better? And that's where Excel Solver will come in handy. So what I'm going to do is I'm going to start out with some placeholder values for the order interval, and I'll pick a random number. Again, it doesn't matter what you pick, I'll just pick 100. And if I were to order every 100 days, again, the first thing I need to do is I need to figure out what the associative order quantities would be. So for hex nuts, it would be equal to 100 divided by 365 multiplied by the annual demand. So the order quantity here would be 5,479 units, roughly. And for MOLLE screws, it would be 100 divided by 365 multiplied by the annual demand volume for MOLLE screws. So you see, I would get an order quantity of about 8,336. Now, just as before, I'm going to again calculate total costs as a sum of 3 components. And I'm going to start out with the annual order placement cost. Remember, the first question is, well, how many orders would I actually place over the course of the year? Well, if I place an order every 100 days, the number of order placements per year would be 365 divided by 100. And then if I want to get the annual order placement cost, I simply multiply that by K, the order placement cost per order. And now I add to that again the holding costs. Remember, we have 2 products, so we have 2 order costs. We have 2 order costs. Looking at hex nuts, that will be the hex Q divided by 2 multiplied by the corresponding holding cost value. And I'm adding to that the holding cost value for MOLLE screws, Q over 2 multiplied by H. So now you see, for this arbitrarily chosen value of 100 days as an order placement interval, I would end up with a total cost figure of $650. So again, I've been able to lower my total cost relative to the scenarios that we've previously calculated. The question, of course, is could I do even better? And that's where Excel Solver comes in handy. So let's open up Solver, and all I need to do is set up the optimization problem, which in this case is really straightforward because all I want is Excel to minimize total costs, and my objective function is the total cost figure right here. And be sure to click minimize because that is what I of course want to achieve by changing the value of the order interval. We do not need to put in any restraints. I'll just click on solve and we get a solution that is that we should place an order every 113 days. If that's what we do, we would be ordering 6,202 units of hex nuts at a time and 4,341 units of MOLLE screws at a time. Doing so would actually cut down our total costs really significantly if we compare it to the initial scenario. And again, that's because we're able to dramatically lower our order placement costs as we combine orders for the two products into single order placements. On a final note, I want to say that of course these numbers here are really small, so you might say, all this effort to save a couple of $100? But of course remember, scale is your friend here. So once we look at more products, more units, these numbers become much more dramatic. And you see that in this case, we're able to cut costs by over 25%. So I hope you can understand better this idea of global optimization in the context of minimizing costs associated with managing multiple products at the same time. Please come talk to me if you have any questions.